The third type of claim we look at is where we are given a claim comparing numbers from two independent groups. This could be something like a greater percentage of boys have an iPhone than girls. The rule of thumb formula for the comparison between two independent groups, 95% margin of error, is this. You work out the margin of error for the first group and the margin of error for the second group, you average them out and you times that by 1.5, where N1 is the sample size from the first group and N2 is the sample size of the second group. Again, this formula only works where the percentages are between 30 and 70%. Let's have a look at a simulation. We can see group 1 has a proportion in the population of 55% and group 2 has a proportion in the population of 35%. Both of the sample sizes are 1,000. We can see we've got the top group here where we get a 55 from this random sample and 37 from a random sample of group 2. We can see the differences between them is 18%, so that gets graphed down the bottom. If I take another sample, we can see it comes out slightly different. This time the difference was 26%, so that gets graphed down the bottom. Again, like I did last time, I'll have the simulation come through and I'll have it take 1,000 samples. We can see this gives us a margin of error from our simulation of 13%, which matches reasonably well with the rule of thumb of 15%. Again, if I make these sample sizes bigger, we can see that it makes the confidence interval smaller. Likewise, if I make sample sizes smaller, the margin of error gets wider. And again, if the percentages become particularly small, the margin of error also becomes smaller, which means the rule of thumb isn't valid because it's outside of that 30 to 70% range. If you want to have a play around with this simulator, there's a link in the notes. Let's look at an example for when we're making a claim for a comparison between two independent groups. We have this claim here: a greater percentage of boys have an iPhone than girls. We're also given some extra information. The survey questioned 540 males and 430 females. 43% of males said they owned an iPhone, and 36% of females said they owned an iPhone. Looking at this, we can see the number of males who said they owned an iPhone was 7 percentage points higher than females. We need to see if the 7 percentage points difference from the sample is actually enough for us to conclude there is a difference back in the population. Again, we need to go through the same 4 steps. We need to find the margin of error, which is 1.5 times the average, which is half of the two added together, of 1 over square root n for each sample size. This gives us 0.0684, which is 6.84%. We need to construct the confidence interval, which is 7% plus or minus 6.84%, which gives us between 0.16% and 13.84%. We need to interpret what this means. It's a fairly safe bet that the percentage of male Kiwi students who own an iPhone is somewhere between 0.16 percentage points higher and 13.84 percentage points higher than the percentage of female Kiwi students who own an iPhone. And finally, we need to make a judgment. This confidence interval does support the claim that a higher percentage of male Kiwi students own iPhones than female students because the confidence interval is entirely positive. It's really important that you keep these last 2 statements as separate sentences, as that's something that the markers have specifically said, as often when people combine them into one sentence, they end up mixing them up. Again, the judgments that we can make for this is the same judgment as we can make with the previous type, the comparison within one group. The confidence interval doesn't support the claim because 0 is inside it, or it does because the interval is entirely positive or entirely negative.